Okay, we're going to look at a topic called trigonometric graphs. For short, we'll put that down as Trig. Okay, so we've got a graph that looks like this. This is called the graph of y equals sine x. It's got some specific features. It goes up to 1 and it goes down to -1. And it's got something which we call a period of 360 degrees. Okay, now if you think about the word period, periodical, that means something that repeats. So it says that the sine curve repeats after 360 degrees. So after 360 degrees, it would start to continue to behave as it did at 0. So from 0 to 360 degrees, we would call that the period of the sine curve. We've got another curve that's got this kind of shape. It goes up to 1 and down to -1, and this time it's got a period again of 360 degrees. And we call this curve y equals cos x. So you can see that sine x has got a kind of snake type shape. It goes up to 1 down to -1. It's got a period of 360 degrees, meaning that after 360 degrees it's going to start to repeat itself. Well, the cosine curve's more got a kind of U shape. It goes up to 1 to down -1, but it's also got a period of 360. So this notion of it starting and then dropping, that starts to happen again at 360 degrees. Okay, now what we can do is manipulate these curves, both y equals sine x and y equals cos x, and that's what we're going to start to look at just now. Okay, so let's introduce these two letters. A is called the amplitude. The amplitude of the curve is half the total height of the curve. Okay, so it's half the total height of the curve. We would call that the amplitude. Then we've got B. B is the number of complete periods. So that's after it repeats, remember. So the number of complete periods, we might call that cycles of the curve. So we can see that that would be one period of that curve, and then it would start to repeat. Here that would be one period of the curve, and then it starts to repeat. Okay, so let's first of all look at a curve and call it A sine bx. And then we'll think about one that we might call A cos bx. But let's start with A sine bx. Okay, so what we're tasked with here is to find out what A and B is in this case. And we've got this curve, which is it's a sine curve, we're told that. Okay, so A, remember that A is the amplitude, and the amplitude, remember, is half the total vertical height. So the total height of the curve, and we half it to get the amplitude. Okay, so that should be quite easy. We can see that the curve goes up to 5, and it goes down to -5. Well, if you think about that, that's a total height of 10. So -5, -4, -3, -2, -1, 0 is 5, and then another 5 to go up to 10. So between -5 and 5, there's the bottom of the curve, there's the top of the curve, that would be its total height. So that's 10 then. So you half that to get the amplitude, and half of 10 is equal to 5. Okay, B is the number of complete cycles in 360 degrees, the number of periods. Well, the period is when the thing starts to repeat. So we can see that it climbs from the x-axis. So when does it start to climb from the x-axis again? It starts to climb from the x-axis again here. So that means that that must be one cycle. Okay, and then we've got a second cycle, so that is 2. Now, crucially, let's go back to B. This is the number of complete periods, cycles in the curve, and let's just finish that off in 360 degrees. So just include that in, right? So that's really important. This is the number of complete periods, number of complete cycles in the curve in 360 degrees. So we can see that there's 1, and then it starts to repeat, and there's 2. Okay, so b is equal to 2. Okay, let's try another one. So this time let's go for this one. Okay, we're told that the curve is of the form a sine bx. We need to find a and we need to find b. Okay, so the curve goes up to 4 and down to -4. That's a total height of 8. Half that to get my amplitude, and the amplitude is equal to 4. What's b again? Let's go back to the note. B is the number of complete periods, number of complete cycles of the curve. So it's the number of complete cycles of the curve in 360 degrees. Okay, so let's see. So there's one complete cycle of the curve. How do we know? Because it starts to repeat itself again. And there's a second complete cycle in the curve in 360 degrees. Therefore, b is equal to 2. Let's try a third example. Okay. The curve is of the form a sine bx, and again, same as before, we need to find a and b. What's a and b again? A is the amplitude, that's half of the total vertical height. So it goes up to 7, down to -17, down to -7 rather, up to 7, down to -7, that's 14. Half that to get the amplitude, and that's 7. B is the number of complete cycles in 360 degrees. So there is one complete cycle. How do I know? Because it's starting to repeat itself again. Okay, there's a second complete cycle, so that's 2, and there's a third complete cycle in 360 degrees. So b then is equal to 3. Let's try another example. Okay, the curve now goes up to 10 and down to -10. It's of the form a sine bx. I want to find a and b. Okay, A is the total height of the curve, halved, so it goes up to 10 and down to -10. That's 20. Half that to get the amplitude, that's 10. Okay, what's b? If you read back your note, b tells you that that's the number of complete cycles in 360 degrees, so that's 1. Starts to repeat. 2. And 3. Now, I've then put down b is equal to 3, but that's not correct, because crucially, what does your note say? It says b is the number of complete periods, that's the number of complete cycles. So I've counted then 1, 2, 3, but it's the number of complete cycles in 360 degrees. Now what I've done is just counted that there's 1, 2, 3 and 180 degrees, but it's the number of complete cycles in 360 degrees. Well, there's 2 lots of 180 will take me to 360, so that will be 1, 2, 3 and another 3. So the crucial thing is it's not the number of curves that you can see, it's the number of curves in 360 degrees. So there is 1, 2, 3 and 180 degrees. So how many would that be in 360? Well, I would need to double it, and b would be equal to 6. Let's try another. Okay. The curve is of the form a sine bx. What's a and what's b? Well, a is easy. Right, so it's half the total vertical height, so it goes up to 6 down to -6, that's a total height of 12, but I need half that to get 6. It's then how many complete cycles do I have in 360 degrees? Well, there's 1, 2, 3, 4 that I can count, but that's 4 in 180 degrees. So how many would that be in 360? Well, I would need to double it because there's 2 180s in 360, so that would be 8 curves in 360 degrees. Okay, let's try another. Okay, the curve now goes up to 5 and down to -5. And my diagram ends at 90 degrees. It's of the form A sine bx. What's A and what's B? Okay, A is the amplitude, that's half the total height. So the thing goes up to 5 and down to -5. So if you count between -5 and 5, that's 10. Only half in that, and that's 5. B is the number of complete cycles in 360 degrees. That's what the note tells you, the number of complete cycles in 360 degrees. Well, I can count 1, 2 complete cycles in 90 degrees. But it's not the number of cycles you can see, it's the number of cycles that are in 360 degrees. So there's 2 in 90, there's 4 90s in 360, so that's 4 lots of 2. B is equal to 8. Okay, here's another 2, so let's focus on this one. Okay, A is the amplitude, that's half the total vertical height, so the curve goes up to 8.5 and down to -8.5, so 8.5 plus another 8.5, that's 17. Half that to get 8.5. Okay, B is the number of complete cycles in 360 degrees, so I can count 1 cycle, so that's 1 cycle in 60, but how many 60s are in 360? That's 6, so that's 6 times 1 then, that's 6. Okay, next one. Goes up to 11 and down to -11, that's 22, half that to get 11. B, number of complete cycles in 360, okay, so I can count 1, 2, 3 cycles in 180. 3 and 180, how many is that? 360, that's 6. Okay, we're now going to try some examples with the cos x curves. So that's the more U-shaped looking ones. So let's have a look at this one to get going. Okay, so this time it's a curve of the form A cos bx. And we want to find A and B. Okay, so again, A is the amplitude, that's half the total vertical height, so that's easy. Goes up to down 9, goes up to 9 down to -9, that's 18. Half that to get my amplitude, which is 9. B is the number of complete cycles in 360 degrees. So when do we know that a cycle is elapsed? Well, if you think of this, it's almost like the start of a roller coaster. It starts at the top and drops down. Where does that happen again? It happens here. So there is one complete curve and a second complete curve in 360 degrees. That's 2 curves in 360. B is equal to 2. Okay, let's try another. Okay, it's of the form y equals A cos bx. What's A and what's B? Okay, so the curve goes up to 6 and down to -6. That's a total height of 12. Half that to get the amplitude, which is 6. I then count 1, 2 complete curves in 360. B is equal to 2. Okay, next one. A is the amplitude, that's half the total vertical height. Curve goes up to 10 down to minus 10, that's 20, half that to get 10. Let's count the cycles. 1, 2, 3. 3 cycles in 180, so that must be 6 cycles in 360. So there's my first one, second one, and third one. That's 3 cycles in 180, but I want to know how many cycles in 360, so that's 6. Okay, let's try another. Okay, let's have the form A cos bx. What's A and what's B? A is the amplitude, that's half the total vertical height. So it goes up to 4 down to minus 4. That's a total height of 8, half that to get the amplitude, which is 4. Okay, next thing, how many complete cycles are there in 360 degrees? How many complete cycles in 360 degrees? Well, there's first one. Second one, that's 2. Third one, that's 3. Fourth one, so there's 4 complete cycles, but that's 4 in 90 degrees. 4 in 90 degrees. How many 90s on 360? 4, so that's 4 times 4. B is equal to 16. Okay, so there's 6 for you to try. There's a example with sine, sine again, sine, sine, and then there's 2 cosine examples. So for each one you need to identify A and B. Remember that A is half of the total vertical height, and B is always the number of cycles in 360 degrees. So if it's given to you in 360, then you're ready to go with that. But if, for example, it's the number of cycles that you see in 90, you would need to adjust that for the number of cycles that would be in 360. So have a go at those 6 examples for next day.